the algorithm. Setting this up. You're going to write this on your paper, and then you're going to put it in your calculator, and you're going to do it. And just write down the numbers you get. You guys see what I'm saying? So this is the work. Because this would be where you're showing me using the idea with the f and the f prime and all that kind of business. Yes, yes, yes? Obviously, the actual adding and dividing and shit, I don't care about that. It's Math 88 shit. But setting it up, that's the work. Okay. Okay, so try those out. We're going to finish off chapter 4 right now, do 4-9, and then we'll call it a day. I'll do a little preview of 5. Now, we've done the idea of 4-9 already. I don't know if I'm pretty sure I've used the title of 4-9, that word before, antiderivative. Have I used that word before? So in math, in general in math, when you learn a function, you try to see if there is an inverse function. That kind of makes sense. Or if you learn a process, you try to figure out what's the reverse process. So we've learned differentiation. We've learned how to take derivatives. We have talked about, here's an example problem we looked at already. What do you got, Jeff? If that's true, then what would this be? So this is the main idea. This is just differentiation in reverse. Yes?
X to the third plus cosine x plus c.
Big ass. Let me make that a big ass C. Wow. Yeah, and actually we've done a problem together on the board where we did a couple steps, where it was f double prime, and then we did a couple. It was a polynomial, and those are like easy as shit. So let me get into a couple of things. Is it always going to be? It's not all. Oh God, it's not always going to be this easy. In fact, there are some f primes I could write down here that it is impossible to find this. Let me show you. So if I said f prime of x is e to the x squared, what's f of x? I just gave you the answer, which is impossible. Right? You actually cannot find what some people call a closed form for this answer. If you took Calculus 2, you can find a series answer to this, but you can't find a single function answer to this. There is no function that I can just write in one little piece whose derivative is this. And think about it. Why does that kind of make sense? I could put one thing here and then it makes it so much easier. Let me guys see. So this is not possible in certain ways, right? It's possible in one way, but that way involves an infinite number of terms in the answer. That's a little bit not satisfying, right? Write the answer down. It's going to take the rest of my life and my kids' lives and their kids' lives and their kids' lives, and I'm not going to write the answer. Okay, sure. Well, watch this. Let me see if you guys get this. What if I said, okay, f prime is 2x e to the x squared. What's f? Why is that one doable? And can you guys see why it's doable? So it's got an e in it, right? So it must have come from that. Because when I take a derivative of an e, that EP stays the same. So I know it must have come from something like this. And let's check what we have so far. What is the derivative of this? It's itself times. What's the derivative of e to the x squared? It's going to involve a what rule? Chain rule. What's the derivative of x squared? 2x times e to the x. There you go. So just put a plus c and I'm done. So what was this missing? It was missing that chain rule piece. And not every function that's missing that piece is impossible. But this is one example where it's impossible. But if it's missing that chain rule piece,